In this video, we'll adjust the linearity. What that does is set the peak positions to be at the correct energy. You want to do this with a sample such as copper that has a very distinct low energy and high energy peak. You can do it with other peaks like nickel, other materials, but sputter cleaned or heated clean copper works well because it has a low energy and a high energy peak. So step one is to adjust the sample distance and elastic peak. So the elastic peak alignment, I've started it, turn it on, and okay, so we can see that our sample distance is off a little bit. So I'm going to move a little bit closer. Okay, so that sets the correct distance from the sample to the end of the analyzer optics. That's step one. Okay, so we're on copper, so what I want to do next is look at the low energy peak. To do that, I'll change the parameters on the alignment to go from 30 EV to 90 EV, because the peak position that we want to get is 60. The other thing I'm going to do is I'll just apply this right now, because when you do this calibration, you also, after you set the elastic peak, you want to put the beam voltage up to 3000. I got to keep tapping this because my mouse doesn't work properly on this laptop that I'm creating this video. You'd probably just scroll up. Okay, so I'm up to 3000 volts. You're going to always take your Auger data typically at 3000 volts. Sometimes you'll have to go a little bit lower if your sample is charging, for example, to alleviate charge. But in general, 3 kV to acquire Auger data, 2 kV for the elastic peak. All right, let's acquire this alignment. And what we should see is a peak that we want to have differentiated at 60 EV. Okay, here's our peak. Now one little trick you can do is I can hit the differentiate button up here, differentiate, and I'll get my differentiated data. So I want that differentiated bottom peak to come in at 60. So now what I'll do is I'll adjust the offset knob on the front panel, and the offset's very sensitive, for 60 EV, and then lock it down. Okay, that's pretty good. And now we'll stop the alignment. Now we'll go and change the parameters. In this case, the high energy peak comes in at 920. So I'll go from 900 EV to 940 EV. And acquire. Okay, there's our high energy peak. Let's go ahead and differentiate that. And we can see that's off just a little bit. So now we adjust the gain to bring that to be centered at 920 differentiated. And you just take an average. You can see there's a little bit of instability there. That's normal, especially if with 1 EV per step. If I change that to 0.5 EV per step, I would have better resolution. Okay. And stop the alignment. That's fine. Okay, now we're going to go back. Our beam voltage is at 3 kV. I'm going to do the alignment again. This time 2 kV settings, and I'll auto set the beam to 2 kV. Now we'll do the elastic peak alignment one more time. So we've adjusted the offset and gain pots on the front panel of the controller so that the low energy 60 peak and the high energy 920 peak are coming in at the correct spots. Now we acquire the elastic peak, and if the peak is off just a little bit as it is now, we go to the hardware settings, hardware properties, and the beam voltage scale factor, we want to change that just a little bit. So let's just pick at random. It's at 0.997 now. I'll go to 0.996 and we'll just see which direction we're going. Hit apply. Yes. Okay, that's too far. So let's try 9965. Apply. Yes. That's good. Okay, we'll say OK. Yes, save the changes. So now what we've done is we've set the position of the elastic peak first, then we've adjusted the offset and gain pots on the front panel of the microCMA controller so that the copper low energy 60 and high energy 920 peaks are in the correct spot. Come back without changing the gain or offset again, come back, reacquire the elastic peak, and if it's off a little bit, you adjust the beam voltage scale factor in the hardware properties. When those three things are done, which they are now, every time you set the elastic peak distance, your target, your specimen to the end of optics distance, so that the elastic peak comes in at 2000 volts, you'll be at the maximum signal point, the best focused point, and the linearity will be correct, meaning that the energy peaks of your specimen will be at the correct energy.